minus what? 3 square root of what? Over what? All of it.
3.
I think you see how you test? You test, no problem. But the calculator is not going to help you if you don't understand what you're trying to do. So watch something interesting here in example number 2. Given sine t is this, right?
Yes.
And whatever, find cosine of what? So let's say before this problem happens, I want to do a strategy. Talk to me about your strategy. Forget about the solution. What's the first thing you should determine?
Know what the quadrant that happens?
Know where the angle is, right? So T in which quadrant, right? After that, what are you going to do? Draw a picture to help you, right? You see, those are the fundamentals. Don't change from a problem to a problem. They just remain the same, right? So what's something? It said sine t. So where is t? Let me try to determine where t is. So remember how I have all? You can take what? It says sine t is negative. That's what it said, right? Where is sine t negative?
3.
So sine t is negative 3 and what? Is that right? 1.
All,
Yeah,
all.
that's right. All the first quadrant, all positive.
Yes.
Can be.
Sine.
Sine positive can be. Okay, 3 and what? 4. Also, cotangent t is positive. So where is cotangent t is positive?
3.
Cotangent t is positive when we have, I think in the first one, all of them positive, right?
Yes.
So it could be in the first one, right?
Yes.
And then this right here, right?
Yes.
So where is t?
3. Quadrant.
So t is in quadrant what?
Yes.
In quadrant what? Alright, I think now we can try to do something, okay? Here is x and here is what?
1.
And t is, I don't know, right here, okay? We go by the reference angle, right? This is t, right? So he said, now time for the diagram. Sine t is what?
Opposite of 1.
Negative 2 over what?
7.
But you are right. Opposite over what?
Hypotenuse. And the hypotenuse of the positive.
Because of hypotenuse, we don't talk about x and y. Talk about distance, right? If distance in general, no matter what, x, y, positive. Negative is just in reference to where the angle is. So the opposite to that angle, t, turned out to be 2. When you put distance, you can just always put positive. You know it can be negative because it's heat, right? So when you're doing your calculation, you need to be aware which one is positive, which one is what.
Negative.
But as far as 2 is distance, distance is positive, right? So the hypotenuse is what?
7.
7. So that was my first step, determine where the angle is. My second step was to talk about my diagram, right? What am I going to do after that?
Find the missing.
Find the missing, but maybe he's not, I don't give a damn. Find the missing what?
Find the missing.
You're going to use it somehow. So 7, 2, we need the adjacent, right? So I don't know if you want to call it x or whatever, I really don't care. X seems fair. So x squared plus 2 squared will be equal to 7 what?
Squared.
So I think x by itself will be equal to 49 minus 4, which is 40 what? But that's x squared. X is the square root of 40 what?
49.
You like, somebody might say plus or minus. You don't do plus or minus when it comes to distance. Actually here, it's kind of negative, right? But what's the negative in reference to sine what? Cosine, all that stuff. But I can just keep going and that would be 3 square root of what?
5.
How so? Because the square root of 45, as you very well know, square root of 9, square root of what? Which is 3 square root of what?
You see what I'm doing?
Is that okay? So you see the idea here, in all the trig problems related to the fundamental, now, and when you take your Cal 1, it is the same thing. I can give you, in the homework, you have like a lot of problems like this. Yeah.
One of them, they give you just the coordinate points, do you just plot the coordinate point and then do the diagram like that?
Yes.
Okay.
Because the coordinate also tells you if it's in which quadrant, right?
Right.
So you see the idea, it is the same bullshit every time. I wanna know where my angle is, I wanna draw a diagram, find the missing side, then, now I can do whatever he wants me to do. What does he say? Find cosine of what? And don't answer more than what he's asking already. So what is cosine of d? Cosine of d is just really adjacent over what?
Is it?
But the adjacent is what?
It's 3 square root of 5.
Negative
Negative
3 square root of what?
5.
Over the hypotenuse, which is,
Isn't it? Adjacent.
yeah, adjacent. Negative.
You said hypotenuse.
Jason.
Adjacent over hypotenuse.
Yeah,
No.
adjacent.
Oh, yeah.
No, just. This is what happened when you went to Cancun, look at this. You know Ford manufactured Ford Fusion in Mexico, right?
I don't know.
So they found, from the manufacturer, which is really amazing, they found $1 million worth of weed in the Ford. Nobody knows what happened, how they got there. Nobody knows anything. They use, for the spare tire, that's what they use. The dealership on them, like, he's trying to show the car to somebody, like, hell? Then no one knows what happened. And now they think that this has been going on for like a long time.
The Ford diesels, the ones we have over here, they're the most stolen ones, and they take them to Mexico.
Yeah, the ones that, rough. Take a look at example number 3. It's really the same what idea. Should we just call this homework? And then you could show me tomorrow what you did with it. And also, if you have a question, you can ask me tomorrow that question, right? Right? So now we are beginning the graphic, the beginning of what? Periodicity. Well, what are the hallmark of all trig functions that are periodic? They just keep repeating themselves, right? Oval periods, intervals. First of all, what the hell is a period? Well, you see the circumference of the unit circle is just 2 what?
Goodbye.
Thus, if we start at a point, any point, and go by full rotation, we go back to the same one. Basically, that's what the hell is saying. Start at any point, go by full rotation. Whether you are going in full rotation in the positive direction or the negative direction, you're going to go back to the same one. Which means if I want to graph sine alpha, sine x, or cosine, or tangent, or cotangent, there is really no need to graph any of them beyond 2 pi in a period, because that same graph in the period is going to repeat itself over and over and over. What's the graph? It's a collection of the points, right? Well, if every point repeats itself, doesn't that mean the graph repeats itself? So what do we know about periodic function? Well, the most important function in your life is periodic. Really? Your heartbeat. What happens if it stops being periodic? You go to 10 seconds back. What happens if the period, is the amplitude of the period changes? Time to figure out what the hell happened. Sometimes even it's like your heartbeat is not regular, what do they put? The pacemaker, right? Then you have a problem. Because somebody can hijack the pacemaker. Some of them have Wi-Fi signals. If they log on to your Wi-Fi signal, they can turn it off. We have really, really interesting watch the sine, cosine, the definition of a period. You see, every time you add 2 pi, it's the same, we get back to the same, right? Now also for all of them, cosecant, all of them. So pay attention. Like the sine and cosine function, the tangent and cotangent function also repeat themselves in an interval length of 2 pi. In addition, the tangent and cotangent also repeat themselves in an interval of shorter length, which is what? Pi. That's only the tangent and what? Watch something. The periods of sine, cosine, secant, cosecant is 2 pi, which means sine and cosine, cosecant and secant repeats themselves every 2 pi, multiples of 2 what? Pi. The period of tangent and cotangent is, they do still repeat themselves every 2 pi, but we can find a shorter interval of repetition, which is only pi. So for tangent and cotangent, it's enough to have multiple of pi. Let me tell you what that means. Let's say I have tangent of 47 pi over 4. Okay? Or let's say tangent of alpha plus 47 pi. That's the same. Isn't that a multiple of pi, yes or no? So that's the same as tangent of what? It don't matter. Multiple of pi. Cotangent alpha minus 276 pi. Multiple of pi, yes or no?
Yeah.
Cotangent what? But for sine, cosine different. They have to be multiple of 2 what?
2 pi.
So if I have cosine of alpha plus 16 pi. Is 16 pi a multiple of 2 pi, yes or no?
Yes.
So that's just cosine of what? So if I have a cosine of alpha plus 17 pi,
No.
but what do I do in this case? I say this is cosine of alpha